Hi, so now we're going to look at hydrolyzing nitriles. So if you remember, nitriles are this group here, this carbon-nitrogen triple bond. And so what we're going to do is break this triple bond with water and in this case acid. So we see sulfuric acid, so H2SO4, you should think it's a good acid. And what to keep in mind is that it's this carbon that's going to be at the base of the carboxylic acid. So what we're going to end up doing in this case is we're going to keep the cyclohexane. We're going to draw our bond out, and now this carbon that we're drawing was the carbon that we had over here. And then we add the water molecule, and so that gives us our double bond to our oxygen and our OH. And so what we get is from this nitrile group, we get this carboxylic acid. And if you notice, all the other carbons stay the same, and the only thing we change is this nitrile. Do remember though, acid and water does react with other groups. So if you had an alkene in the molecule or something else that's receptive to acid and water, it would react with it as well. Alright, the other thing you can do is you can react nitriles under basic conditions. So if we look at this, we're probably going to do the same thing at this carbon. Alright, so let's draw the carbon framework just the way it is until we get to that carbon. Alright, now we have the carbon at the base of the carbonyl, at the nitrile, sorry, and we're going to make a carbonyl. And in this case, it's going to stay with a negative charge, and then we get a sodium with a positive. Alright, so typically, if you do it under basic conditions, you're going to get this idea where we're going to have the anion on the oxygen. Because remember, carboxylic acid is slightly acidic, and you have a strong base, and so that base is going to pull off that proton. Right? It's going to eat up that proton and give you the negatively charged oxygen. So typically, what people do is then work this up with a little bit of acid. And then we can put the proton on at the end to get our normal carboxylic acid. Alright, now nitriles are a little bit resistant to hydrolysis in most cases. So in most of these, what you would see is, if you were in the lab, you'd actually have to add a little bit of heat. And that probably goes for both of these reactions, unless for some reason that the nitrile you're working with is particularly susceptible to hydrolysis. But typically they need a little push, and so the way we can help push them along is add a little bit of heat.